Hey guys, so in 4.4 we're going to start to transition from combining polynomials together to create larger ones to taking those large ones and breaking them into smaller pieces, okay? So before we can get into factoring or breaking those polynomials into smaller pieces, what we need to do is we have to quickly review prime factorization, greatest common factor, and least common multiple. Okay, so the goal here is to be able to use those things for both integers and now monomials as well. Okay, so things that have variables in them as well. So first we'll start with prime factorization, which is writing an integer as the product of primes. And remember, a prime number, or any number that can only be written as a product of itself and 1. Okay, so the only factors are itself and 1. Okay, so we'll break these down. Remember, you probably learned these prime factorization trees, so 35 breaks down to a lot of things, but we'll do 7 and 5. Actually, I'm sorry, they're not a lot of things, it's just 7 and 5, okay, and these are both prime numbers. Okay, so prime factorization of this is 5 times 7. Alright, the second one, 43 is prime already, right, because it can't be broken down at all, so that's it. And 42 breaks down to, let's do 7 and 6, which breaks down to 3 and 2, so we have 2, 3, and 7. So 2 times 3 times 7 is the prime factorization of 42. Now the greatest common factor, right, the GCF, you usually did this with small numbers, okay, so you're able to do it in your head, right, so these are the common, the biggest factor that's common to all of them, okay. Now working with monomials, it makes it a little bit more difficult, so what we're going to do is we're going to learn how to do this with using prime factorization, okay, so start with simply 8, 12, and 30, so you need to write the prime factorization out of each of them. Okay, so you should be able to do this, right? The prime factorization of 8 is 2 cubed, the second one is 2 squared times 3, and the last one there is 2 times 3 times 5. Okay, now once you have the prime factorization of everything you want to find the GCF of, right? First thing you're going to do is you're going to look for just the common factors, right? Just common factors. So that means ones that appear in all of them. Okay, so 3 does not, and neither does 5. 2 is the only thing that appears in all of them. And once you find the common factor, then you take the one with the smallest exponent, and that's your GCF. And the answer there is just 2. So the greatest common factor between 8, 12, and 30 is 2. Now, you could do this as well in this other simple type example, right? But there are variables involved here. So in order to do that, first we start with the coefficients, right? So let's find the GCF between 8 and 16. 8 is 2 cubed, 16 is 2 to the 4th. Okay, the common factors there are 2, obviously. The smallest exponent is cubed, right? So the GCF for the coefficients is just going to be 8. Now, what to do with the variables? Well, the same exact process as what to do with these common factors, right? You just take the common variables, right? So A, B, and C all appear in all of them, right? If D just appeared in one but not the other, you wouldn't be able to use D in the greatest common factor, okay? So these are just common ones. So for each one, you take the smallest variable, okay? So for A, the smallest variable is 1, so A. For B, the smallest variable is 2, so B squared, and for C, the smallest variable is 1. So 8ab squared C. Now, least common multiple, you're probably familiar with finding these just by counting the multiples and figuring out what this first one is that all of them share. So 8, 16, 24, so on and so forth, 30, or 12, 24, 36, so on and so forth, and 30, 60, 90, until you find one that all of them share. Okay, you could do that, but we're going to be working with more complicated stuff, so we need to use our greatest common, or our prime factorization method to find this. Okay, so remember what all the prime factorizations were. 2 times 3 times 5. Okay, now for least common multiple, in order to find this, right, you actually take not just the common factors, but any factor that appears, so 2, 3, and 5. So 2 times 3 times 5, and for the exponents for each of them, you just take the largest exponent that appears in any of them, and that's what you go with. So for 2, it's going to be third power. For 3 and 5, it's just going to be first power. So we work this out. We get 2 to the third is 8. 8 times 3 is 24, and 24 times 5 is 120. So the least common multiple of 8, 12, and 30 is 120. Right? For the second one, it's same idea. All right, 2 to the third, 2 to the fourth. We've got that prime factorization down. All right, and exact same way. All right, so we're going to use 2 to the fourth here, so it's going to be 16. Notice that this note at the bottom, all right, coefficients are always positive, okay, so don't worry about that negative 16, just kind of throwing you off, okay? So 16 is what we're going to use, 2 to the fourth, and we have the A, the B, and the C. Now, if there was a D in one of them but not the other, you would actually use the D for this one. It's any variable that appears, not just common ones, and pick the biggest exponent. So A to the third, B squared, C cubed. So the answer would be 16A cubed, B squared, C cubed. More complicated examples. So prime factorization of giant number, right, 924, you got to use a calculator to guess some numbers to figure out something that goes into it. All right, I'm going to use 11 and 84. That's the first one I found. Okay, so 11, 84. Well, 11's already prime, so I can circle that and let it go. 84 breaks down to lots of things. Okay, we could use 7 and 12. Right, 7's prime. So, 12 breaks down to 3 and 4, which breaks down to 2 and 2. So we have all this stuff here. Okay, so when we combine these, right, we get 2 squared times 3 times 7 times 11. That's the prime factorization of 924. Now we're going to find some greatest common factors and least common multiples. All right, for 20 and 28, I've got to get the prime factorization out there for all of them. Of course, if you want to use your own method with these small type numbers, that's fine. Okay, so we've got 20 breaks down to 4 times 5, which is 2 squared times 5. And 28 is 2 squared times 7. Okay, so for the greatest common factor of this, GCF, we take just the common factors and the smallest exponents. That's 2 squared, which is 4. And the least common multiple, okay, we take all factors that appear, and the largest exponent goes with each of them, so that would be 2 squared times 5 times 7. And let's see, 2 squared times 5 is 20, times 7 is 140. Now number 3, we're going to do the same process. Alright, with, oh, not 80, I don't even know why I wrote that. That was pretty dumb. Okay, so we've got 90, 100, and 120. Alright, get the prime factorizations for all of them. So we can use 9 and 10 for 90, which is 2 times 3 squared times 5. Okay, for 100, it's 10 squared, which they both break down to 2 times 5, so 2 squared times 5 squared. And for 120, alright, we can use 12 and 10. 12 breaks down to 4 and 3, and we have 3 2's, so 2 cubed. We've got 3 and a 5. Okay, perfect. Now, the greatest common factor of that, remember for greatest common factor, you take just the common factor, so we're going to be looking at just 2 and 5 here, because 3 doesn't appear in all of them. Alright, you take the smallest exponent that goes with all of them, so 2 to the first times 5 to the first, which is just 10. And the least common multiple, you take any factor that appears in the largest exponent that goes along with it. Alright, I'll write it out since it's kind of long. 2 cubed times 3 squared times 5 squared. Alright, we got to multiply this out. It's a pretty big number. So we've got 8 times 9 is 72 times 25, which gives us 1800. Okay, so GCF 10, LCM 1800. Alright, now these are monomials. They're going to have variables in them. So, you still have to find the prime factorization of coefficients to work that out. So 2 cubed and 2 squared times 3. Okay, now for the GCF and the LCM. Alright, GCF, use the same rules as we did above. Okay, so we're going to use 2 squared for the GCF because they're common, and the smallest exponent, which is 4. Now you're going to take just the common variables, right? A and x both appear in both, and you take the smallest exponent for both, which is 1 for both of them, so 4ax. And for the LCM, you take both factors for the coefficients, so and the largest exponent, so 2 cubed times 3. 2 cubed is 8. 8 times 3 is 24. Okay, you can probably figure that one out in your head. And you take all variables that appear and the largest exponent with both of them. So 24a squared x squared. Number 5. Same concept. 32 breaks down to 2 to the 5th power. 120 we've already done. I think that was, let's see, 2 cubed times 5. Nope, 3 times 5. Oops, I can't erase that. Times 3 times 5. Right, and 42 breaks down to 6 and 7, which is 2 times 3 times 7. Perfect. Now, for the GCF and the LCM. Okay, we're obviously going to be having the number, the coefficient, the x's, and the y's. So for the numbers, the coefficients, we take common terms, which is just 2, and the smallest exponent, which is the first, for the GCF, and the both variables that appear in all of the monomials there, and the smallest exponent that goes with both of them. So x to the first and y cubed. For the least common multiple, we take the 2, the 3, the 5, and the 7, right, and the highest exponents that go with each. So let me write that out since it's so big. 2 to the 5th times 3 times 5 times 7, right? So we have to multiply that out real big. 2 to the 5th is 32 times 3 times 5 times 7 gets you 3,360. Okay, now you got to put the x and the y in there, and the largest exponent that goes with both, so x cubed y to the 4th. And that one's finished. Now the last problem here. Okay, so we've got to find 132, 44, and 99 prime factorization. Right? 132, that one's kind of hard to find. Divide it by 2, and you get 66, which is 6 and 11. So we're going to have 2 squared times 3 times 11. 44 is just 2 squared times 11. And 99 is going to be 3 squared times 11. So lots of 11s showing up in there. That's going to be important. Now to actually find the GCF and the LCM. GCF, common coefficients, right? The only one is 11, so we're using 11. Now just the common variables, which is just x, the only one that appears in all of them, and the smallest exponent is to the first, so 11x. The LCM, right, you take all the terms that appear, or all the coefficients that appear in your prime factorization with the highest exponent. So 2 squared times 3 squared times 11 is 4 times 9 times 11, which is 396. Now we take both variables with the highest exponent that they appear with, so x squared y to the 4th. That is all for this section.